Hello, Chem 120. We are looking at Chapter 4, Section 5, so you can get in your textbook and read that section and follow along. We're going to be calculating the concentration of a solute in a solution in units of moles per liter, which is the definition of molarity. So, moles per liter. And then use solution concentrations and calculations. We're also going to be able to describe how to prepare a solution of a given concentration from the solute and solvent or by dilution of a more concentrated solution. So most chemical studies, as you know, require quantitative measurements. So we need to measure accurately using units by measurement tools. Experiments involving aqueous solutions are measured in volumes of solutions rather than masses, because when we're measuring aqueous solutions, liquids we want to measure the amount of liquid. Again, that's in volume, so using a graduated cylinder, using a pipette, as opposed to finding the mass of it. Solution concentration, which is expressed as molarity, again, moles per liter, relates the volume of solution in liters to the amount of substance in moles. And again, if we know moles, we can find grams of a substance. So how many grams of something in how many liters or milliliters of that. And therefore, we have our solute, which is the substance that is being diluted in solution. So we can find, if we know moles per liter, we can find how much mass of something we're going to dissolve in how much liquid. So again, concentration, there's a qualitative and a quantitative aspect to concentration. Of course, qualitative is saying, oh, is it concentrated or is it a dilute? Obviously, think about Kool-Aid. If you had a concentrated Kool-Aid, you would have a much darker solution, as opposed to if it was diluted, it would be a lighter color. So we could tell that that's a qualitative measurement. And then, of course, we have quantitative, where we're looking at the amount of solute and solvent in a solution. We look at mass percentage and molarity. So a solution is made up of a solute and a solvent. The solute is that which is dissolved into the solvent, what it is dissolved in. So here we go. We have a picture down here. It says we measured out exactly 1 liter of water, which was slowly added to this flask. And this flask contained 25 grams of copper sulfate pentahydrate. When enough water had been added, so the solution volume was exactly 1 liter, approximately 8 milliliters was left over from the original. Okay. So again, molarity is moles of solute per liters of solution. You need to know this. And its units are moles per liter. So if I had 1 mole of sodium chloride, that means if I added up the mass of Na and the mass of Cl, which would be, I added up 1 sodium and 1 chlorine. If I had 58.44 grams of NaCl, that would be 1 mole of NaCl. If I dissolved this much grams in 1 liter of solution, I would have a 1 molar solution. That would be its concentration. Again, we can say that the molarity is capital M, or we can say that it is moles per liter. Either M moles per liter or capital M are the units for molarity. So, looking at solutions, a solute is usually in solid form, and it's a soluble salt or a soluble covalent compound, but it needs to be soluble. A solvent is the major component, which is usually water. So, how do we prepare a solution of known concentration? So we have our volumetric flask, And this volumetric flask has a line on there, and there's all different sizes of volumetric flasks. In this case, it's a 250 milliliter volumetric flask. So we can get to a very accurate reading of volume. And we're given a known amount of our solute, in this case 0.435 grams of potassium permanganate. So that potassium permanganate is first dissolved. So we put the potassium permanganate into the flask and put a little bit of water in there and dissolved it. Then we added enough water into this flask to that exact mark so that it was exactly at 250 milliliters. This is just kind of reiterating what we did. We weighed out the solute, we transferred it to the flask, we dissolved it in a volume of solvent, and then we filled the volumetric flask to the calibration mark, and then we inverted the flask many times to ensure that it was a homogeneous mixture. To figure out the concentration of this potassium permanganate, we take that 0.395 grams of potassium permanganate. Obviously, when we want to go grams to moles, so this is just the molar mass. So we added up 1 K, 1 Mn, 4 Os, so grams to moles. So we know how many moles of our solute, the KMnO4. So that's our moles. And remember, it's moles per liter. Well, we were told that we had 250 milliliters, so we just converted, we moved the decimal spot back 3, so 0.250 liters. So to find the concentration, it's just moles divided by liters. And when we do that, we get 0.010 capital M, or molar, 0.010 molar solution. And actually, we started with 3 sig figs here and 4 sig figs here, so I should have 3 sig figs for my final answer. So it should be 0.0100 would be the more accurate answer. Let's look at a practice problem. We're going to dissolve 5 grams of nickel chloride hexahydrate in enough water to make 250 milliliters of solution. Let's find the molarity. Again, we want moles per liter is molarity. So we have grams. Let's get to moles. Grams of nickel chloride hexahydrate. So this is the molar mass of 1 nickel, 2 chlorines, 12 H's, and 6 O's. So we have our moles of nickel chloride hexahydrate. I need per liter. Again, we want to get 250 milliliters in 2 liters. So here's our 250 milliliters. There's 1,000 milliliters in 1 liter. Moles divided by liters. Here we go. We took our moles. 0.0210 moles divided by 0.250 liters. And we should get 0.0841 molar solution. What if we were looking for ion concentrations in a solution? Let's say we have copper 2 chloride, and when we dissolve this in solution, we know that it's breaking apart into its ions. So we have copper 2 plus ions, 1 copper 2 plus ion, and 2 chloride ions, and each chloride ion has a -1 charge. So this is telling us, by looking at this, that for every 1 copper 2 plus ion in solution, there are 2 chloride ions. So let's say we're told that the concentration of this copper chloride solution was 0.3 molar. We're just going to look at that mole to mole ratio here. That means this is a 1 to 1 to 2 ratio. So if the concentration of copper chloride is 0.3, that means the concentration of copper 2 plus is 0.3 molar. It's a 1-to-1 ratio. Our chloride is going to be twice. Notice that for every one of these, there's 2 of these, is going to be twice the concentration. So the chloride concentration, since there are double them, is going to be 0.6 molar. So here it wants to know the molar concentration of each ion present in the following solutions. So if I had 0.1 molar of KCl, remember KCl is going to break into the K plus ions and Cl minus ions. So KCl, there's one K in KCl and one Cl in KCl. So it's all a 1 to 1 to 1 ratio. So if I have 0.1 molar KCl, I'm going to have 0.1 molar K and 0.1 molar of Cl. Let's look and see what magnesium nitrate does. MgNO3 2 is going to break down into magnesium plus 2 ions. And in this compound right here, we have one magnesium ion. And each nitrate ion, so this is plus 2, each NO3 minus 1 ion, it's telling me that there's 2 of them. So if I have 0.25 molar MgNO3 remember that's a 1 to 1 to 2 ratio. If that's the concentration of magnesium nitrate, that'll also be the concentration of magnesium. So 0.25. And to find the nitrate, it's going to be double that. So 0.25 times 2 would be 0.5 molar for my nitrate ions. Let's look at an example problem. We're told that lithium carbonate, Li2CO3, here it tells us our FW is formula weight, so this is how many grams per mole, is a salt used to treat manic depression. What mass of lithium carbonate, so we want grams, is required to prepare 500 milliliters? So I'm just going to right off the bat, we want 0.500 liters, right? That's the same as 500 milliliters of a 0.25 molar solution. All right, so I'm just going to do a little, oh, that wasn't a good spot, right here. Remember, molarity is moles divided by liters. So if I cover up, and I'm just going to put a little X here. If I cover up M, put my finger over it, molarity is moles divided by liters. If I cover up liters, if I wanted to find liters, it's moles divided by concentration, or moles divided by molarity. Let's fix that now. And if I want to find moles of something, which can get me to grams, I would do concentration times volume, or molarity times liters. Okay, so I've got my volume and I've got molarity. So what I can do is I can say that moles of Li2CO3 is equal to the concentration of it times its volume in liters. So let's do that. 0.250. Remember, that's capital M is moles per liter. I want to show you how this works out. Times 0.5 liters. Notice that liters and liters cancel out. So I'm going to be left with moles of solution. And let's get our calculators out. That should give us 0.125 moles of lithium carbonate. And then to find out how many grams of lithium carbonate that is, I'm going to take 0.125 moles. And remember the formula weight that they gave us. So I got to have moles on the bottom. 1 mole of lithium carbonate, I'm not going to write Li2CO3, is equal to 73.9 grams of Li2CO3. I guess I should write it. I always tell you to write your units. So I'm going to take that. Let's get my calculators out, and I'm going to do 0.125 times 73.9. And I get 9.2375. And let's see how many sig figs I started with. I started with 4 and with 3, so I got to end with 3. I'm going to say 9.24. So this first one will give me 9.24 grams of Li2CO3. Let's look at the next question here. I'm going to erase this. Now this next one wants the volume. So again, if I look up at my circle here, remember molarity is moles per liter. So here I want volume. So I'm going to do moles divided by molarity. It tells me that it contains 0.100 moles of lithium carbonate, and it gives me the molarity. So to find the volume, we're going to do 0.250 m divided by 0.01 moles. And remember that molarity, I'll even write it out here, is moles per liter. So notice that moles and moles cancels, leaving us with liters, which is the volume that we want. So let's get our calculators out. And we should end up with 25 liters. And let's just double check here. We've got 3 sig figs and 3 sig figs. So we would say 25.0 liters. We would want 3 sig figs. And let's look at this last one. It wants the volume. So to find the volume, just like we did, we need to have moles divided by molarity. So notice we are given molarity here, and we're given grams of lithium carbonate. So we got to get that grams into moles so we can do our moles divided by molarity. So I'm going to say 8 grams of Li2CO3. We were told the molar mass up above, so I got to have grams on the bottom. 73.9 grams for 1 mole. So that'll give us moles. So 8 divided by 73.9. I got 0.1082544 moles. I'm not going to round it to the very end. So moles divided by molarity, which is 0.250 moles per liter. Moles and moles will cancel. And ending with 3 significant figures, I got 0.433 liters. Now let's say we want to prepare a solution by dilution. Notice here that we have 0.1 molar of potassium dichromate, and so we've got that right here. And notice that I'm going to take my 5.00 milliliter pipette. So we're going to take some 5 milliliters of our concentrated solution. So I know the volume and I know the concentration of my concentrated solution. Then I'm going to put that in there, and I'm going to fill up, so I'm diluting this all the way up to the mark of however big that flask is. In this case, it's a 500 milliliter flask. So how do we figure out the concentration of my diluted solution? That's what we're going to look at here. So when more solvent is added to a solution, the concentration of solute decreases. Think about that. When I add more water to something, it becomes more dilute. And if you think about that, if my moles stays the same, I'm not adding more of my solute or more of my solid, and the denominator increases when I add more solution, it would be like if I had a fraction of 1 over 2 and then I have a fraction of 1 over 8. We know that 1/2 is much bigger than 1/8. So since that denominator is increasing in magnitude, that concentration must decrease. Now there's 2 ways to do this dilution equation problem. Let's say this student adds 50 milliliters of a 0.515 molar HCl solution to a 500 milliliter flask. She then fills the flask up to the calibration mark with water. What is the new molarity of HCl? So we're starting with volume, my 50 milliliters. I want to get to liters because remember this unit is moles per liter. So starting with milliliters, the first thing that we did was we just went milliliters to liters. So we did 50 divided by 1,000. So if we want to even kind of simplify this part right here, we're starting with 0.050. Is that right? 1, 2, 3. Yep, liters. Okay, then we're multiplying it by the concentration, because remember 0.515 molarity is moles per liter. So that'll get our initial 50 milliliters canceled out. Now that leaves us with moles of HCl. And then again, we want the new concentration. So if I have moles of HCl right here and divide it by the new volume, that gives me the new concentration, moles per liter. So taking my new moles and dividing it, again, this is just the conversion from milliliters to liters. So 500 milliliters, I could just take my new answer divided by 0.5. Or we can use a simpler equation. I like this one, M1V1. So this 1 stands for like my initial molarity and my initial volume, equals M2V2. My second or my final molarity times my final volume. So let's look at an example problem here. What volume of a 12 molar hydrochloric acid solution? So this is our concentrated because it's 12 molar and it wants to prepare 100 milliliters of 1 molar. So obviously 12 molar is my concentration. So for my M1V1 equals M2V2, I'm going to say my 12 molar, it wants to know what volume of it. So I'm going to say V1 is equal to M2, my second molarity, which is 1.0 molar, times volume, 100.0 milliliters. Okay. Now, notice that I have molarity and molarity. My volume, if this is in milliliters, I can leave it in milliliters in this case. Just my answer over here when I find V1 will be in milliliters. So let's simplify. We'll simplify the right side first. 100 times 1 is obviously 100. Is equal to, divide both sides by what my V is attached to, 12. So 12 times V2, so 100 divided by 12. And I got 8.3 milliliters. So I need 8.3 milliliters of my 12 molar hydrochloric acid. Put it in a new flask. And that would make, if I added 100 more milliliters of water, it would be a concentration of 1 molar. Let's look at the second one. What is the concentration of a solution prepared by diluting 25 milliliters of 14.8 molar? So that's my concentrated. So I'm going to do M1 is 14.8 molar. And I am taking 25 milliliters of it is equal to M2, I don't know. And it says a total volume of 1.50 liters. Now in this case, notice I have different units here. I've got 1.5 liters on the right and 25 milliliters on the left. So I'm going to make them both liters. So 25.0 milliliters is 0.025 liters. Just going to cross that out. Okay, so I'm going to divide both sides by 1.5 liters. And I get M2 is 14.8 times 0.025 and divide that by 1.5.247 M. There we go. So I started with 14.8 molar and I really diluted it down to 0.247 molar.